questions on the homework assignments thus far? Any questions on the homework assignments thus far? Also, if you've not turned the worksheets in from the factoring assignments, I need those in by the end of the day tomorrow. So if you haven't turned in factoring 1, 2, or 3 in, get those done and get them turned in tomorrow. Okay? All the ones that have been turned in thus far have been graded and put in WinGauge. So if you're not sure, you can check WinGauge, and that will let you know if they have been turned in or not. Yes. All right, guys. So let's put the Chromebooks away, computers away, and we're going to be talking about adding and subtracting rational expressions today. Adding and subtracting. Now, whenever we add or subtract two rational expressions, we need the denominators to be the same. If the denominators are the same, we can go on and add the numerators together. So here the denominators are the same. We just add or subtract the numerators, what's on top, as long as the denominators, the bottoms of the fractions, are the same. So if we look at the first example here, 7 over 4x plus 3 over 4x. Well, since the denominators are both 4x, the denominator will stay the same, and we will add the numerators together. So here, 7 plus 3 would be 10 over 4x. And if we can reduce these after we finish adding or subtracting, we need to do so. Well, 10 over 4 would reduce to what? 5 over 2 x. Because they are the same amount. Because it's the same as saying 1/3 plus 1/3 would be 2/3. Because the amount of the whole that we're talking about is 4x. 2x. So the answer for this here is 5 over 2x. Any questions on the first one? Let's look at the next one. Now for this here, the denominators are the same. We have x plus 6 and x plus 6. So that would be the same. We just need to subtract the numerators here. So we would have 2x minus 5. Now we do need to make sure that the numerator doesn't have any factors. We can factor it down or have a greatest common factor. Well, 2x minus 5 doesn't. That's as simplified as it gets. And there's no way we can simplify anything on top and bottom, because the x minus 6 is really one whole term. The addition, subtraction, stick it together. The 2x minus 5, we really can think of it as one whole term. So that there is as simplified as it gets. We can't do anything else to it. Any other questions on this here? Let's look at these next two. Well, for number one, we have 8 over 12x minus 5 over 12x. Well, you probably see that, well, 8 and 12 do have a greatest common factor that we could probably simplify, yes? But for us to be able to add or subtract, we need the denominators to be the same. So at this point here, I wouldn't want to simplify 8 over 12x, because if we do that, the denominators wouldn't be the same anymore. So we can't do that quite yet. But since the denominators are both 12x, we can subtract the numerators. We can subtract the numerators from each other. And 8 minus 5 is 3. We can simplify because 3 and 12 do have a greatest common factor of 3, which simplifies to 1 over 4x. Yes, 1/4. And that there would be the answer. Let's do two more like this. We'll do this one here and one more. Well, here the denominators are both 3x squared. So we can go on and add the numerators. Well, 2 plus 1 is 3. Well, this here definitely does have something we can simplify on top and bottom, which would be our 3's to give us 1 over x squared. And we get this here. Any questions on any of this here? Okay. Let's look at one more. I'm not going to too concerned with number 3. Let's look at number 4. Well, here, the denominators are both the same, x squared plus 1. So we can go on and add the numerators, which would be 2x squared plus 2, because they're not like terms, so we're really just rewriting it with a plus sign in the middle. Now, is there anything we can simplify? Because we do have x squared and x squared, yes? But unfortunately, the 2x squared plus 2 is stuck together as one whole term. But is there something we can do with the 2x squared plus 2? Unfortunately, these x squared plus 1 get stuck together as one whole term. I can't just take out the x squared. Right, because the top does have a greatest common factor of 2 between 2x squared and 2, yes? If we factor that out, what I'm left with is x squared plus 1 over x squared plus 1. Because when I factor that 2 out of the top, we do end up with an x squared plus 1. Well, since that is the same on top and bottom, it would cancel out, leaving us with 2. So whenever we have these here, the numerator, if we can simplify it in any way, shape, or form with the greatest common factor or sets of parentheses, we need to do that just to see if something on top and bottom will match up. Now, it won't always guarantee that something will, even if it does factor on top, but it's good to go on and do that so that we can see if there is. Any questions on this here? We like addition and subtraction so far? Well, this works out very nice if the denominators are what? The same. Well, the denominators are not always going to be the same. Now, if the denominators are not the same, what we need to do is actually make them be the same. Because you've worked with this before, taking 2/3 plus 2/4. Because if we have two fractions with unlike denominators, we make the denominators be the same with a least common multiple. Because if I look at 3 and 4, we're looking for the first number that they would both be the same, which is 12. So to make 4 12, well, we would multiply it by 3 over 3. To get the 3, we would multiply it by 4 over 4 so that the denominators are both 12. And if we do this here, well, 4 times 2 is 8. 4 times 3 is 12. Plus 2 times 3 is 6. 4 times 3 is 12. And now that the denominators are the same, we can add the numerators. And 8 and 6 is 14 over 12. Now we do have like terms on top and bottom, which would really reduce to 7/6. Now 12 is what we call the least common denominator because it's in the fractions, or least common multiple. 12 is the smallest number that I can turn both 3 and 4 into. I mean, there are other numbers that we can turn 3 and 4 into, because we can look not at 12, but 24, 36. Any of these, we could turn both 3 and 4 into. But doing that, because here we already had a greatest common factor of 2 between the top and bottom, anything higher than that will just make more common factors between the top and bottom that we'll have to simplify out later. Now we can do this exact same thing with our polynomial expressions. Yes. We want to get these to be the same using the least common multiple. So now we'll work through this here with least common multiple. There'll be a question or two on the test about this. But the real key behind this is we're wanting to use this so when we start adding and subtracting these rational expressions, we want to be able to get the denominators to be the same. We want to see how we do that. So whenever we look at something like this here, so 4x squared minus 16 and 6x squared minus 24x plus 24. What we want to do is we want to factor these down completely to see the parts or their components that make up both, and then see what we need to do to get them to be the same. So exactly, 4x squared and 16 do have a greatest common factor of 4. And if we factor it out, 4 out of 4x squared will leave us with x squared minus, if I factor 4 out of 16, I'm left with 4. Now we can factor x squared minus 4 because it is a difference of perfect squares. And that would be x minus 2 and x plus 2. So that's factored as simplified as it gets. So that'll help us when we're trying to find the least common multiple, trying to figure out what we need to get to so that these two here will be the same. Now the next one we'll look at is 6x squared minus 24x plus 24. There is a greatest common factor of 6 that we can pull out, or divide each term by 6. So if I take 6 out of 6x squared, we're left with x squared minus, if we factor 6 out of 24x, we're left with 4x plus 4. If 6 factored out of 24 would be 4. Now we can factor this. So since the third term's positive, the signs are the same and they match the sign of the middle term, which would be negative and. Now the factors of x squared are x and x, because that's the only factors of x squared. Now the factors of 4 are 1 and 4 or 2 and 2. Which one would we want? 2 and 2. So that is that one factored all the way down. Now the goal with least common multiple is, again, the term least common multiple is kind of an odd phrasing. I've always found it weird because greatest common factor, we're looking for kind of the biggest number that will go into all of them. So we're not looking for the greatest number overall, we're just looking for the one that's going to go into everything. Least common multiple, we're looking for the biggest set of numbers in each term to use for the overall number. Or really, we're trying to see what do I need to change or add to this one and this one so that they are the exact same. So that they are the exact same. Now, whenever we look at the two, especially with the numbers. We'll look at the numbers first and the parentheses next. There's two ways we can go about it. One of them is dealing with prime factorizations, breaking the number down into its smallest numbers being multiplied together. Well, 4 would be 2 times 2, because that's the only numbers that multiply together to get it. And 6 would be 2 times 3. Or another way we can talk about this is kind of the factor trees. If you remember doing those, breaking it down to the simplest numbers we can get and multiplying those numbers together. Right, and when we get to the least common multiple, when we look at two numbers, we look for whichever one has the most of those given factors. So for 4, it has 2 twice, and whichever one has the most is what we take. So since this has 2 2's, we'll take 2 2's. We're not concerned with this one here, because we only want whichever one has the most of the given factor. Now, 6 has 1 3, so we need 1 3. Well, 2 times 2 times 3, well, we know is 12. And that's one way we can get at this for numbers. Now, another way we can look at this is, well, I can take the multiples of 4. 4, 8, 12, 16, 20, and we're going to continue on like this here. And again, for least common multiple, we're looking for the smallest number I can turn both 4 and 6 into. I can also do this with 6. 6, 12, 18, 24, 30. Well, the first number that both 4 and 6 are the same is 12. So if we're looking at least common multiples for even more numbers than that, well, I can just keep listing the factors out, and the first number that all of them line up with is the least common multiple. So here the least common multiple is 12. So if I was wanting to try to make these the same with the numbers, well, the first number I can get them both to be the same is 12. Any questions on this here? Okay. Now, we need these to be the same. We need our sets of parentheses to be the same. And up to this point so far, have we had any way to change an x plus 2 into an x minus 2? Well, no, we haven't gone over any ways that I can just magically change a sign from one to the other without changing everything entirely. But I still need the sets of parentheses to be the same and match up, yes? So if I can't change the sign, can I multiply things to them to get them to be closer to being the same? Well, yes. Because if we look at this one here, I'm going to go on and get a highlighter before I start underlining even more than I already am. This here, what is it missing that this one has? Because it does have an x minus 2, yes? But what does this one over here have? Also, 2 of them, yes? So if this one over here had one more x minus 2, it would be closer to being the same, yes? Because if they both had 2 x minus 2's, they'd be closer to being the exact same thing. Would y'all agree with that? So a part of the least common multiple is, well, we do need an x minus 2, because both of them have at least 1. But we can't just get them to go away. We need 2. Because if this one has 2, well, the other one needs to have 2 as well. It's nice that the other one does have 1, but we need to have a total of 2. Any questions on this here? Well, what is this side missing that this side has? So the least common multiple for this here is just this here, 12 times x minus 2 times x minus 2 times x plus 2. So if we were adding two rational expressions that had these as the denominators, what we would need to get the denominators to is 12 times x minus 2 times x minus 2 times x plus 2 for us to be able to add them together. And that's what this least common multiple is. We're trying to figure out what is the smallest thing we can get the 2 to be so that we could add the numerators together. Any questions on this here? So a lot of times when I look at this here, I will grab all of one and then see what does the other have that this one doesn't. Okay, the x plus 2, and we have it. Let's look at the next one, 6x squared minus 54. And 9x squared minus 54x plus 81. Now, the first thing we need to do to find the least common multiple is going to be to factor these. So if we look at the 6x squared minus 54, well, the first thing we can do is what? Factor out the 6, because 6x squared and 54 do have a greatest common factor of 6. And if we factor the 6 out, we're left with x squared minus 9. Well, our x squared minus 9 is a difference of perfect squares, which would be our x3 and x. And I could have written it as x minus 3 times x plus 3. The order of those two really doesn't matter. Now that brings us to our other one here. Now there is a greatest common factor of 9 that we can factor out of all three terms. If we factor out a 9x squared, we're left with x squared minus 9 factored out of 54 is 6x plus 9. Now this here will factor. Because the 9 is positive, our signs are the same and they match the sign of the middle term, which would be negative and negative. Our factors of x squared would be x and x. And the factors of 9 that we would want to use would be 3 and 3. Any questions on how we got to this point here? Least common multiple. Now we can look at the 9 and 6 first. I have a feeling y'all like doing just the multiples of 9 and 6 and seeing where they match up more than the primes. So if we looked at both of these here, we could say that 6, we have 6, 12, 18, 24. 9, 18, 27, 36. Well, the first number that matches up is 18. So the smallest number we can make both 6 and 9 be is 18. Now we need to figure out the least common multiple with our x plus 3 times x minus 3 and x minus 3 times x minus 3. What do we know we'll need for certain? So we will need one of both. We'll need an x minus 3 and an x plus 3. Do we need anything else? We need another x minus 3. Yes. Since one of them has 2, we do need 2 for them to be the same. Since the other one does have 1, that's fine because I can multiply it by an x minus 3 for these to be the same. For this one here, we can multiply it by an x plus 3 for them to be the same. And we can use 2 and 3 to get these overall to be the exact same. Any other questions on this here? All right. If we're good with this here, we're going to look at one more of these before we start actually adding and subtracting. Now the last one we're looking at is this one here. Find the least common multiple of 5x cubed and 10x squared minus 15x. Now, 5x cubed, there's nothing we can do with it. We can't factor it down or simplify it any further than it already is because it's a single term. But if we look at 10x squared minus 15x, we can factor this by factoring out a 5x from both terms. If we factor a 5 out of 10, 10 divided by 5 is 2. And if I factor an x out of x squared, we're left with x minus. If I factor a 5 out of 15, or 15 divided by 5 would be, and x divided by x would be 1, it simplifies out completely. So now that we have these both factored completely, or as simplified as we can get them, we want to see what do we need to do to make them be the same, or what will make them be the same, or the smallest version that we can make them both be the same as. Because that's the real big focus here, is getting them to be the same. So we do have 5 and 5x cubed, yes? Well, the 5s are already the same, so part of the least common multiple would be 5 because they are already matching. One of them has x cubed, the other has x. So if I want them to be the same, we would need them both to have x to the third. Is there anything else we need? And this here would be the least common multiple between these two. And that's it. Any questions on any of this here? All right. Let's look at the first one here. Whenever we start working with these here, these addition subtraction problems of rational expressions, and the denominators aren't the same, the first thing I would do is try to factor all the denominators as far as I possibly can. That way we can see what this least common multiple is, what we need to do to get them to all be the same before we start adding and subtracting. Now looking at the first one here, 9x squared is a single term. There's nothing we can do to get it to be any different, so we can leave it alone. But the 3x squared plus 3x, we can do something with it here. We can factor out a 3x, because both the 3x squared and 3x do have a greatest common factor of 3x. And if we factor the 3x out of 3x squared, we get x plus 1. Because the 3x squared divided by 3x, or if we take 3x out, 3 divided by 3 would be 1. X squared divided by x would be x. And our 3x divided by 3x would be 1. So we do have both denominators as simplified as possible. Now we need to see what we need to do to get them to be the same. So we look at this one here, 3x times x plus 1. Well, what do I need to do to this to get it to be the same as 9x squared? Because we do have a 3x and we want it to be what? 9x squared. What can I do to 3 to make it become 9? Times it by 3. And then to get the x to be x squared, we multiply it by x. And what we do to the bottom, we also have to do to the top. Just like we did with the beginning with our, I think it was 2/3 and 2/4. So now does this side have everything that this side has? Because it would have the 9x squared, yes, over here? With our 3x and 3x? So that's everything that the 9x squared has, yes? But the 9x squared is missing something. What is it missing? The x plus 1. So over here, we're going to multiply top and bottom by x plus 1. So that we can get these to be the same. Now on both the denominators, because we'll have 9x squared times x plus 1, which is going to be 9x squared times x plus 1. And over here, we're going to have 9x squared times x plus 1. So here, really, we're saying that the least common multiple for the denominators is 9x squared times x plus 1. Actually, at this point, it would be the least common denominator, but they're essentially the same thing, just applied in a different way. Now, for the numerators, we're actually going to multiply it out. So for here, we're going to multiply the 7 by both terms. So we'll do 7 times x, which is 7x. 7 times 1 is plus 7. Here, 3x times x is going to be 3x squared. Any questions on any of this here? Do we have the denominators the exact same? Yes. And since the denominators are the same, well, if you'll let me do this, now jump back up, we can go on and add the numerators together. Well, between our two numerators, do we actually have any like terms? Well, no. 3x squared, 7x, and 7 are not alike, so we can just go on and add them, which gives us 3x squared plus 7x plus 7. Now, at this point here, we would need to see if the numerator would factor at all, if it can factor in any way, shape, or form, and unfortunately, or fortunately, this is as simplified as it gets. 3x squared plus 7x plus 7 doesn't factor. Is there any way, other ways that we can simplify this down? Let's get a highlighter. Could I simplify this 3x squared and 9x squared? Because remember, these three here, the 3x squared plus 7x plus 7, because of those addition and subtraction signs, are holding it together as one whole term. I can't just simplify the 3x squared and 9x squared. If we had it multiplied out front, then we could, or two things being multiplied together, we can simplify that, but we can't do it if it's added and subtracted. So this here is the final answer for this here. Any other questions on this here? All right. We'll finish up with this last one here, and then we'll finish the rest of the notes tomorrow. Now, the first thing we need to do here is to see if there's any way we can factor the denominators. Well, 12x squared does not factor any further than what it is because it's only one term. Now, with our x squared and x, we do have a greatest common factor of x, which we can factor out. Now we can look at getting these denominators to be the same. So we're going to multiply the top and bottom of both of these here by a certain amount to get the denominators to be the same. Now on the one on the left, we do have 12x squared. On the right, we have x times x plus 1. So what is the one on the right? What do we need to add to it or multiply it by? X plus 1, because this one over here is missing an x plus 1, yes? So we will need an x plus 1 over x plus 1. Now this one over here does have an x. Does the 12x squared have an x there? Well, yes, it actually has two of them, so I don't need to multiply it by the x because it's already here. Now if we look at the x times x plus 1, what is it missing that 12x squared has? 12 squared. Because we do have the 12. Here we have x squared, here we have x. So the 12x squared has two x's. The x times x minus 1, x plus 1 has 1, so I need one more x for them to be the same. So if we multiply these here, the denominators are both going to be 12x squared times x plus 1. 12x squared times x plus 1. Now the numerators, here we're going to multiply through by 8. 8 times x is 8x. Plus 8 times 1 is 8. Over here we're going to have 12 times x, which is going to be 12x squared. Now we can add these together. And again, just like the previous one, well, we don't have any like terms, so we can just add them together, which would give us 12x squared plus 8x plus 8. Now we can't say that this is the final answer because if we look at the numerator, 12x squared plus 8x plus 8 does have a greatest common factor of, yes, 4 would be the biggest one. And if we factor a 4 out of 12, 8, and 8, 4 factored out of 12 would give us 3x squared plus x plus 2. Well, the 4 and 12 are both being multiplied on the outside, yes? So 4 over 12 would actually reduce to 1 over 3x squared. So the final answer for this here is going to be 3x squared plus 2x plus 2 over 3x squared times x plus 1. So we'll finish up these node sheets tomorrow. I was planning on doing that, having that done originally, but that's all we're going to talk about